Right, question 7. 60% of voters at a certain polling station are women. Voters enter the polling station one at a time. The number of voters who enter up to and including the first woman is denoted by X. State a suitable distribution that can be used as a model for X, giving the value of any parameters. State any necessary conditions. Right. Well, this is, I've already told you what this is, but it's kind of an obvious thing, isn't it? We're saying now, it's a success. This is going to sound odd, but it's a success if we find a woman. I'm sorry, that's what the question says. So we're gonna stop. We're gonna count the number of people who come in up to and including the first woman. So that's the classic geometric, isn't it? We're going to stop after we reach our first success. So it's a geometric distribution. Okay. Giving the values of any parameters. What do we have as parameters in this one? The probability. We're assuming that the probability of a success is 0.6, 60%. So it would have a parameter, a value of p of being 0.6. State any necessary conditions for this distribution to be a good model. Well, what needs to happen? We know these conditions for the distribution. So what do we think? Any ideas how we might write this? Go on, Ben, what do you think?
Constant probability of finding.
Okay, it needs to, that probability needs to remain constant, doesn't it? So what did I write? Yeah, well, the probability remain constant. Of the voter being a woman. And the second thing that we could put is that the voters, individual voters, must be independent. Okay, so we need to somehow get in this idea of things need to remain constant, and that the voters need to be independent. You know, it needs to not be that if you get groups coming of all the same gender or whatever. Right, so now use the distribution stated in part 1 to find certain probabilities. Well, we know this about geometric now. This is just applying those things. So the probability of x being 4, we think about what must have happened for x to be 4. There must have been 3 failures, followed by a final success, and that would make x equal 4, and that is 0.0384. 3 significant figures. And the other one, probability of x being greater than or equal to 4. This is this one that's always that little bit more difficult to think through. You've got to remember what's happening here. In order for x to be greater than or equal to 4, we must have had 3 failures. So the condition for this is that we must have had the first 3 being men, and so that would be 0.064. Oh, 6. And there we go. That's quite a nice 8 marks for doing that. Great. And that's maths. Thanks, John.